All right, this is example 3 in 9.2 for 20-1 math. It does look more difficult than the first two examples, and it is more difficult, but it's not to the point where it's not doable, I suppose. The biggest thing I think is that when we talk about a function being, above the x-axis or below the x-axis, that's only when, something is greater than or less than 0. That's not what happens in the original setup of this question. It's greater than 12. So the first thing that we're going to do is just like we would in a regular quadratic, I am going to get one side of my equation or inequality equal to 0. So now looking at 2x squared minus 7x minus 12 is greater than 0, I just want to write that the solution is when y equals 2x squared minus 7x minus 12 is above, because it's greater than 0, and I'll put that maybe in a bracket, greater than 0, below that, the x-axis. And that's really what I've been saying the last couple examples, but that's one of those things that I think is worth talking about, that if my function is greater than 0, then when I graph that function, it has to be above that x-axis, because that's where the values of the function or the y-coordinate would be positive. Now, this question is more difficult because in order to graph y equals 2x squared minus 7x minus 12, it's not as easy to factor. Right, my a value isn't positive or negative 1 for that matter, it's a 2, and most students that have had me have seen this t-chart before. We are still looking for a number that adds to the coefficient on the x, that's -7 right there, but now the number that it needs to multiply by is a times c. Well, in this case that's 2 times -12, so we have to multiply and get -24. Now, getting to this point is really, really important to be able to do, because now what we're going to look at is, can we find any factor? And I'm a little worried that this isn't going to factor nicely, because the candidates are -1 times 24, -2 times 12, -3 times 8, -4 times 6, and that's really it. Now, even if I put that negative on the other factor, none of those multiply to -7. And add to -7. Oops. What that means then is that this does not have nice perfect numbers, and likely it means that they want us to use our calculator for that, and you can look at the graph that way. I do want to show you what that looks like. The one thing that's really important is I still actually know almost as much information as before. I know that a is equal to 2, so my parabola opens up. I know that my y-intercept is at 0, -12. Now that's not quite enough to get a good sketch of the graph. Bare minimum, we would want to see x-intercepts as well. So what we're going to do then is we're going to grab our calculators and we're going to make our calculators do the graph for us. All right, so with our calculators in hand, we're now going to graph the function. Now, again, I'm not graphing 2x squared minus 7x and then 12 separately. I'm going to graph 2x squared minus 7x, going to hit that right, minus 12. And then I'm going to go to zoom standard, because we're hoping that our x-intercepts will be between -10 and +10. If they're not, we can tweak our windows after the fact. And this is the function that I get. Now, the one thing I do want to show you is, maybe I'll make my y-min a little bit smaller, or more negative, I suppose. I'm just going to make that -15, and I think that's going to be enough to see the entire curve. It is nice to see that this parabola for sure opens up. Didn't quite get the vertex, but that's okay. What we need to figure out is this x-intercept and this x-intercept, because this function is less than 0 in between those two x-intercepts. So greater than this number and less than that number. So in order to figure those out, we're going to go to second trace intersect, or sorry, not intersect, my bad. We're going to go to 0 because we're looking for the x-intercept. I need to be to the left of that x-intercept, to the right of that x-intercept, and the guess should just be somewhere near it. And I get -1.260399. Now, I don't want to have to, write that out more than once. So if you go back to your home screen and you type just x, it will show you the value that you just calculated, which is pretty beneficial when you're trying to deal with, a very, very long non-repeating and non-terminating decimal. So we're going to find the other x-intercept as well. My other x-intercept, I hit the wrong button. I'm going to go to graph, then second trace 0 again. To make your cursor jump a little further, if you hit second and the arrow key, it will actually go a further interval of x, but we don't really need, it's not that bad on this graph. So I'm left of it there, that's good. I'm right of it there, that's fine. The guess doesn't matter so much, and I get 4.76, yada, yada, yada. Now, again, I'm going to go back and I'm going to put that on the home screen, because seeing those numbers together is really enough for us to graph this. And I'm actually just going to pull those values into the notes here, because that does make it a little bit easier for me. It's tough to remember two 10-digit numbers. But what I'm going to do with that is I'm going to use those two pieces of information to not necessarily factor this, but that does tell me where the function passes through the x-axis, which are really, really important points when we talk about solving something like this. So what that allows me to do, and I'll do it in red just because I've written a lot in blue already, is I know that my function looks something like this. Now, again, not drawn fantastically to scale, but that's okay. For a little bit of simplicity, we're going to round these to the nearest thousandth. So this point right here occurs at 4.760, and this point right here occurs at negative 1.260. Now, because I am solving for when my function, I think I said less than 0 before, sorry. So when my function is greater than 0 is when my function is above the x-axis. And what that's going to be, and I'll do them in green here, is there would be an open dot there and everything to the right of it, because my function is greater than 0 over that interval. And it would be an open dot at negative 1.260 and everything less than it or more negative than it. Again, the function is above the x-axis at that point. So the solution, and I want to write out the full equation, and it's a little bit weird to see, the solution to 2x squared, I forgot already, minus 7x is greater than 12 is when x is greater than 4.760 or when x is less than negative 1.260. Now, the one thing that I'd like to show you is there is another way of doing this. And the way that we could solve, and I'll put it again here, 2x squared minus 7x minus 12. Put the 12 on the other side, sorry. When 2x squared minus 7x is greater than 12, what I could do is graph y1 is 2x squared minus 7x, y2 is equal to 12, and the solution is anywhere y1 is greater than y2, which means that y1 is above y2. Now, I do want to show you that because I think it is nice to see that you could do this with left side, right side graphing too. But I really do think getting 0 is much better of a long-term technique. But I want to show you we get the same solutions this way. So I'm going to go back to my calculator and put those in. So 2x squared minus 7x is y1. Y2 is 12. Really importantly, that's not going to be on our window settings. So I'm going to change my y max to just positive 15 so we can see y2. And the solution to this is anywhere that y1, which is 2x squared minus 7x, is above y2, which is 12. So it's going to be from this point to the left and this point to the right. And we can find those points by using second trace intersect. And I hope you can guess what the values are, because when I find this x-intersect, it tells me that it's negative 1.2603. That should look familiar. That's the number we got before. And just to show you that does work, I actually forgot the value. If I type in 4.760, got to hit the 7 though, we're going to see that that's the other point, where my blue graph is above my red graph, the blue being y1 and the red being y2. That's another way of doing this. I don't particularly like this technique, just because you can get a lot of different graphs on your on your scale, and that can make it very difficult to read, and I think pretty confusing as well. This stuff is confusing enough already. We don't need to give it any help. All right, one more example left.